All right, this video is going to be about time-adjusted filtering, which is another very important concept and feature of the dashboard. And to explain it, first we're going to dive into a little theory, and then we're going to dive into the chart and in the dashboard itself and see how it works in practice. So to explain it properly, I'm going to take you back to your favorite moment of high school, and that is I'm going to take you back to math class. Now, don't worry, this is an intro level math class. And we're going to be done very soon, but it's important to still cover a little bit of the basics. Let's have a hypothetical example, and I apologize for a little bit fake text. It's because of the resolution of the screen I'm looking at. But let's review very quickly how this is calculated, right? So we know now that this table is showing how often P1 is put in for each given hour, and the same for P2. Now, how do we calculate this? In a very basic form, we're looking at how many times a certain hour puts in P1. So in this case, hour, and this is obviously a very oversimplified example. And we also only have 12 hours in the day, 0 to 11. But, this is math class. And we know that in math class, we have ridiculous examples like, buying 1,000 watermelons. So let's stick with the notion for the case of explanation that we have a day with only 12 hours in there. But we look at, how many times P1 was put in during hour 0, and then we look at how many days we have, right? So all the occurrences for each hour, basically, because we have, one P1 and one P2 per day, and basically per candle, depends on which time frame you're looking at, but we're looking at the daily. So the total is 100, which means that 32 out of 100 is 32%. So that's how P1 is calculated, very simply put. Same here, 20 out of 100 times it was hour 1, so that's 20%, and so on and so on. So with that in mind, let's look at another topic. Let's say we are here. Right now it's 8 a.m. UTC. The daily P1 was put in at hour 1, and the daily low was put in at hour 3. What we know is that any of the points that are in the past, so in between daily open and the current hour, they can never be the high or the low of the day anymore, right? Like this point, this point, this point, this point, not this point, this point, and this point, they are in between the low and high of the day, right? There you go, more clear. They're in between the low and the high of the day. Now we know time is the chart is moving forward in time. We're not going to go back and take out the high here, or take out the low here and then go back forward in time. It's just simply impossible. So what we know now is that whatever hour is not already P1 or P2 can no longer become P1 or P2 today, right? It is not going to happen. And this is going to become more visually clear in a bit. But this candle, for example, is never going to be the high of the day. It's never going to be the low of the day. This is not going to be the high of the day. This is not going to be the low of the day. It's not going to happen. So we know that this can no longer become P1 or P2, this can no longer become P1 or P2, and this one, same. Everything before the current hour that is not already P1 or P2 will no longer become P1 or P2 for the rest of the day. In the current hour, it could still happen, right? We could still do this, so we cannot discard the current hour. The current hour could still become P1 or P2. So let's assume that right now, this is the current state of things. We have hour 2 is P1, and hour 5 as P2 currently, and we are the current time of day is hour 8, right? So what does that mean? Well, we know we have just established, if we're just looking at the probabilities of each hour being P1, and as we know now that both this can be P1, but this can also still become P1. So this is P1, this can become P1. If we look at this, we've just established that it's currently hour 8, this is P2, this is P1. We know now that none of these can become P1 or P2. It's not going to be, these points are no longer going to be the high of the day or the low of the day, simply because we're not going to go back in time and take out the high and low, just like we discussed. So what does that mean? Well, what time-adjusted filtering does is that when calculating probabilities or statistical occurrences, it deletes whatever can no longer become P1 or P2 because it can no longer happen, and it just looks at what is left and calculates probabilities on that. And that looks like the following. So if we take what we had and remove what can no longer happen, you see the probabilities shift. And well, I say probabilities, but once again, I like to emphasize these are historical occurrences, right? Probabilities, it's there's a nuance. You will see us often talking about probabilities, but remember that these are just statistical data, historical occurrences. But if we remove all the pivots or all the hours that can no longer happen as pivots, what we are left with is this. Instead of 15 out of 100 times, which we had first, now we're looking at a total occurrence of all the pivots are 30. So now we're looking at 15 out of 30 times. So what we could say, and what we say a lot, is that, well, then the probability for the current pivot holding, and again, these are statistics and there's no guarantees, but the probability is for the current hour holding, given the current context, right, given what is still possible for the rest of the day, is 50% instead of 15%, right? Because the 15% takes into account that these can still happen. So basically what you're saying here is, given the current context of the day with what is still possible, let's look at how many times each of these has put in a P1 compared to, you know, all the pivots that can still be P1 for this day. And that way you can, you know, you can diminish or at least get rid of a lot of occurrences that are no longer relevant for today. Right, so this is time adjusted filtering. Basically, in the shorter sense, it just removes the counts, right? So you can see what it removed is 70 counts, because these together were 70. So, and then it recalculates the probabilities or the statistics. It recalculates historical occurrences, the percentage of time it happens based on whatever is left. So let's dive into the dashboard itself and see how this actually comes to fruition. So right now, just real examples that we have daily hour, which is P1, and we have daily, or the daily P1 is hour 1, sorry, and the daily P2 is hour 14. So if we put that in, because you can put this in here, that's why it is here. It's already put, because already daily P1 is at hour 1, and daily P2 is at hour 14, right? So I can just take those from the indicator, hour 1, hour 14, easy enough. Then you can see here the check marks are for just visual aid where it is. And well, not just for visual aid, it's also for time adjusted, but we'll see. And this blue marked row is the current hour, right? So right now it's 3:21 and this is the current hour. I must say though, this doesn't automatically refresh. So if something changes, you know, it's not that if it becomes 4 p.m. that this automatically goes to 4 p.m. That's not how Power BI works. So you got to adjust a setting. Maybe, you know, even if you just do this, that would already change it, change the time, or just take one other day. It's good to mention that, like filter on one different day, or just change any setting, anything. But we can see that right now there's 11.3% chance or historical occurrence given everything that hour 1 gets puts in a P1, and there's a 6.6% historical occurrence of putting in P1 at hour 14. And I'm ignoring P2 just for the sake of argument. It's not necessary to explain the concept. But what we can do now, we have selected the current P1 and the current P2, and then if we press time adjusted, you will see that it will delete everything except for those selected, right? So P1 and P2, and what is still during the current hour or after, because as we have seen, these can no longer become P1, but this can be, and this can also still become P1. So this is how time adjusted filtering works. So now what we see is that for the current data set, for the current occurrences, right, for the current hours that are still left in the data set that are available to become P1 or P2, or where it's still possible that these hours put in P1, P2, so that's the current P1, the current P2, and whatever is in the future. 46.6% of these hours, hour 1 and 14 to 23, 46.6% of the time, if you calculate all of them, it's going to be at hour 1, and 27.4% of the time it's going to be at hour 14. So that's the very basic principle of time adjusted filtering. So there's one more thing I'd like to say about the time adjusted filtering, and that is that if you have two pivots that are both very low probability, I would be very careful with using it. So say for example, I mean this is a weird example, but let's go for it. Say you have our 16 SP1 and our 17 SP2. Then, and let me just do this to simulate. Don't worry about this. This is just because otherwise it won't do the proper calculation. I will explain this later. For now, you just don't worry about it. It's just that it thinks it's later than it actually is. It's mostly used for backtesting, but it's for another video. But let's say it's 6 p.m. right now, and we have 4 p.m. and 5 p.m. as a P1 and P2. Could happen, right? Something like this happens every once in a while. So if you just look at these statistics, it's 1.3% against 0.7%. And you know that both of these barely occur, right? If you look at 6 on 6 days, this is maybe 7 times, this is maybe 5 times that it happened, you know, more or less. So they're both barely happening. That's what you know. So you're not going to give more importance to one over the other if you just look at these, because you know they're both very low probability events. But let's see what happens if we press time adjusted. And then suddenly we have 34% against 17% chance, right? So this is going to give a very skewed view of reality. Now suddenly it looks that this one is way more probable than this one. But the reason this is happening, again, you know, we saw how we recalculate things, is that in this calculation, because both of them barely happen, you know, you're comparing 2 against 3 or something. 2 against 3, which is nothing, right? That's absolutely nothing. So the basic the reason that it's happening is that you're diluting the data too much, right? You have 2 very low probability events. A lot of the high probability events are gone. You have a very small data set left, and then suddenly you're comparing 2 against 3, or in this case 5 against 7 against 5 or something. Which, if you just look at that normally, you say, all right, this is nothing, right? There's no difference here, but time adjusted will give it. So I always say only use time adjusted when at least one of them has like a decent probability, or like 4.1 is already enough. You know, 3 against 1.7, I would probably still do 4.1, 1.7. But these kind of things, you know, if one is 1.3, the other is 2 or something. I mean, as a general rule of thumb, the less data points you have, and with low probability points, you're going to have less data points. The less data points you have, the less reliable it is. So be careful with using time adjusted filtering on those. And with that said, I think that's it for time adjusted filtering. Yeah, that's it. So now you know this, we can actually dive into the practical examples, and we're going to see how we're actually going to apply this, or how we're applying this to the TA to come up with biases, so to say. So now the exciting part begins.